In this class, we discussed about Bernoulli differential equation. We'll start by defining a Bernoulli equation and then demonstrate in an example on how to solve a Bernoulli differential equation. So a differential equation of the form So any differential equation of the form dy dx plus p of xy equals to q of x y power n, where n is any natural number, is called a Bernoulli equation. So the transformation u equals to y power 1 minus n reduces the Bernoulli equation into a first order linear equation in U. So let's quickly confirm this. And it is this same transformation that will help us to solve Bernoulli equations. So multiply So remember, we are saying y power minus n dy dx plus p of x y q of x y power n. So we'll have y power minus n dy dx plus p of x. Now this power 1, this minus n, so 1 minus n equals to q of x, because minus n plus n is 0, y power 0 is 1. Now let u to be given by y raised power 1 minus n. So u is a function of y, and remember y is a function of x. So by chain rule, differentiating both sides with respect to x, we'll have du dx equals to 1 minus n y power minus n, because we're going to subtract 1 here. Then because y is a function of x, we have dy dx. So from which we can make dy dx the subject. So dy dx will be 1 over 1 minus n y power minus n du dx. So if I had called this 1, I call this 2, replacing 1 and 2 in the equation. So let me call this star. We get, so here I have y power minus n dy dx replaced by this. So du dx, then 1 minus n y power minus n plus p of x. But remember, y raised power 1 minus n is u equals to q of x. Then you see this and this cancels out. So we have 1 over 1 minus n du dx plus p of x u equals to q of x. Now multiplying through by this 1 minus n, we get du dx plus 1 minus n p of x u equals to 1 minus n q of x. So if I let p1 to be 1 minus n times p of x and q1 to be 1 minus n q of x. So if I had called this equation 3 becomes du dx plus 1. Okay, so 1 minus n p of x is p1 of x equals to k1 of x. And you see this is the general structure of a first order linear differential equation, which is a first order linear differential equation. So this is a standard equation which can be solved by method of integrating factor. Let's put sense in these steps with an example. Solve dy dx plus y equals to x y power 3. Clearly, this is a Bernoulli equation with n as 3. So we let u to be y raised power 1 minus n, which is y raised power 1 minus 3, which is y raised power minus 2. So we are saying that u is y raised power minus 2. So du dx will be given by minus 2 y minus 3 dy dx. Of course, we are using chain rule and u is a function of y, and then y is a function of x. So this is how we find du dx, from which dy dx will be given by 1 over minus 2 y power minus 3 du dx. I'm simply dividing both sides by minus 2 y power minus 3. So let me call the given equation star. Let me call this 1. Let me call this one 2. So replacing 2 in star, we have, so where is dy dx I replaced by this? So minus 2 y power minus 3 du dx plus y equals to x y power 3. Now the easiest way is to remove this fraction here by multiplying each term by minus 2 y power minus 3. So I'll get minus 2. Minus 3 plus 1 is minus 2. Then this by this will be minus 2x, because minus 3 plus 3 is 0, y power 0 is 1. So if I call this equation 3, so remember 3 has been obtained by multiplying this equation by minus 2 y power minus 3. This is what is giving us this equation. Now replacing this equation 1, which defines u in terms of y, 1 in 3 so replacing 1 in 3, we get du dx minus 2u, because this is u, equals to minus 2x, which is a first order differential equation. So if I call this 4, which is a first order linear differential equation. Now here, remember first order in u will be of this form. So our p of x here is minus 2. So the integrating factor is usually given by e raised power integral of p of x dx, which will be e raised power the integral of minus 2 dx, so which will be e raised power minus 2x. So this is our integrating factor. Now multiply the integrating factor mu of x on both sides of 4. So I'll have e power minus 2x du dx minus 2u equals to minus 2x, which is e raised power minus 2x du dx minus 2 e raised power minus 2x u. Now note that this can be written as d dx times e raised power minus 2x times u. So that's how you can write the left-hand side in closed form. And then minus 2x e power minus 2x. Our interest is to find u. So then integrate on both sides. To get u. So this is to say integral of d dx e power minus 2x u is minus x minus 2x e power minus 2x dx. So when you integrate this side with respect to x, we just remain with e power minus 2x times u. Now this we use integration by parts. So let u to be x and let v be e power minus 2x. So u prime will be dx, or simply du is dx. And then v, when you integrate this, you get minus 2, minus a half. So this is dv. So it'll be minus a half e power minus 2x. So the integral of u dv is uv minus v du. So uv, u is x, v is this, so we have minus a half x e power minus 2x minus integral of v du. So this minus, make this plus a half e power minus 2x dx. And when you integrate this, so you have minus a half x e power minus 2x. This will give you minus a half e power minus 2x. When you multiply that minus a half by this, you get minus a quarter e power minus 2x. And then we have minus 2 minus a half x e power minus 2x minus a quarter e power minus 2x, and then add a constant of integration c. So e power minus 2x u equals to minus 2 times minus a half is positive 1. So x e power minus 2x, and then minus will be plus a half e power minus 2x, then plus c. So divide through by e power minus 2x to get u as x plus, this will give us a half plus c over e raised power minus 2x. So which means u is x plus a half plus c e raised power now positive 2x. But remember, u is y power minus 2. So which means we'll have y power minus 2 equals to x plus a half plus c e power 2x. Or you can say 1 over y squared equals to x plus a half plus c e raised to power 2x. Or you can say y squared equals to 1 over x plus a half plus c e raised to power 2x, which means that y will be plus or minus square root of 1 over x plus a half plus c e raised to power 2x. So that will be the solution. Let's quickly solve another problem on Bernoulli equations. And the problem reads, solve number 2, dy dx plus y over x equals to 1 over x y squared. X is strictly positive. So we rewrite this in standard form and see that we'll have dy dx plus 1 over xy equals to 1 over x y power minus 2. So which is Bernoulli with n equals to minus 2. So let u to be y power 1 minus n, which will be y 1 minus minus 2, which is y power 3. So that du dx will be 3 y squared dy dx, which means dy dx equals to 1 over 3 y squared du dx. So replacing this in the equation, we have 1 over 3 y squared du dx plus 1 over xy equals to 1 over x y power minus 2. So when we multiply through by the reciprocal of this coefficient of du dx, we get du dx plus 3 over x y power 3. Because remember, I'll be multiplying each term by 3 y squared over 1 equals to 1 over x because y power minus 2. So 3 over x because y power minus 2 times y power 2 is y power 0, which is 1. This is the same as du dx plus 3 over x u equals to 3 over x because u is given by y power 3. So this is a first order differential equation. So P of x is 3 over x. So mu, the integrating factor is usually the integral of e raised by the integral of p of x dx, which should be e raised by the integral of 3 over x dx, which is e raised power, when you integrate this, is 3 ln of x, which will give us e power ln of x power 3 using laws of logarithms, which is x power 3. Now, multiplying, if I call this equation star, by mu, we get, so mu is x power 3 times du dx plus 3 over xu equals to 3 over x. So you'll get x cubed du dx plus 3 x squared u equals to 3 x squared. But check that this is the same as d dx of the integrating factor multiplied by u, which is the same as 3x squared. So integrating both sides, with respect to x, we get the integral of d dx of x cubed u dx equals to the integral of 3x squared dx. And this will give you x cubed times u. This will give you x cubed and then plus a constant c. So which means u alone will be given by x cubed plus c divided by x power 3, which is 1 plus c over x cubed. But u was not in the question. Its value is the same as y power 3. So therefore, we'll have y power 3 is equals to 1 plus c x power minus 3, just writing this form. Or we can say y is cube root of this right-hand side. So this is the solution to that given differential equation. So in a summary, to solve a Bernoulli equation, make use of the transformation u equals to y power 1 minus n. And this transformation reduces the equation into a first order linear equation. And then solve the resulting first order linear differential equation using method factor. And once you get the answer in terms of u, remember to replace back the function y to get the solution to the given differential equation.